All right, so I'm going to go over a few problems here. I'm going to go over number 1, 4, and 6. So there are 3 formulas that we're going to be going over. So let's do number 1. First, I'm going to make a copy of this. Then I'm going to go to my favorite website, Whiteboard Fox. I like having the problem here on the page. All right, so a car that has a mass of 1,000 kilograms accelerates with a net force of 2,000 newtons. What is the car's acceleration? Okay, so there's 3 formulas we're going to be using on this problem, and so I'll get to that in a minute. So this one, so the first thing is to draw your givens, right? We know mass is 1,000 kilograms. We know there was a force of 2,000 newtons. What is the car's acceleration? That's our unknown. We don't know what the acceleration is. So what equation are we going to use? Well, there's 3 main equations. There's F equals mass times acceleration. There is mass equals force divided by acceleration. And there is acceleration equals force divided by mass. So these 3 are the formulas we'll be using for the rest of this worksheet. So we have to choose which one will we be using. So we are looking for acceleration, so we're going to use acceleration equals force divided by mass. Now we're going to solve it, right? This is the guess method, right? Givens, unknowns, equations, substitute, no, equation, substitute, and solve. Oh, I messed up. All right. We're still in substitute. So acceleration equals 2,000 newtons divided by mass of 1,000 kilograms. So this is interesting. We're going to go over this in a second. How does newtons and kilograms, how do those cancel out to give us an acceleration? So I'll go over that in a second. So now we solve acceleration. 2,000 divided by 1,000 is just 2, and the units of acceleration are meters per second squared. And that's our answer. So this is what I would like to see on your work. Using the guess method. So let's take a snapshot. And we post that into this. So here's number 1. Just a little smaller. There we go. Now we can see everything. Okay, so let's go over. This will be in a video later too. I'm recording this. So a Newton is measured in N's, right? So 1 Newton is about the force or the weight of an apple. So, so about 1 apple in your hand is about 1 Newton, right? So what is a Newton? So Newton is actually equal to a kilogram meter per second squared. So instead of writing this every time, they're like, well, let's just call this a Newton because it's very important. And what is this? Well, if we can see a kilogram is the mass, and this is an acceleration. That's why, and this is a force, right? So this is where force equals mass times acceleration. So a Newton is just shorthand for kilogram meter per second squared. So it's a mass, and so a mass is moving along, it's accelerating, either getting faster or getting slower, and that is a force. So when we do, like the one we just did was acceleration equals a force divided by a meter. Is that what we did? Yeah. So when we plug in the units, a Newton divided by a kilogram. So remember, a Newton is also a kilogram meter per second squared. What was that? Kilogram meter per second squared divided by kilogram. So the kilograms cancel, and all you have left is meter per second squared. So that is correct, right? Acceleration is meter per second squared. So that's why this works out, these canceling of units. So the main thing we have to remember is that a Newton is a kilogram meter per second squared, a mass times an acceleration. And that is what a Newton is, a force, a weight. So it's the same thing that we measure our weight, when we're measuring the weight of our body. That's a force. So a pound is just another way to say a Newton. I forget what the exact conversion is. Let's look at that real quick. I think it's like 9 or something. How many pounds in a Newton? 0.22. So that's not a very good conversion. So how many? Let's get 1 Newton. 0.22 pounds. How about 1 pound? 1 pound is how many newtons? It's about 4 newtons. So that makes sense, right? 1 pound is about 4 apples. So those are things to remember. 1 Newton is about the weight of an apple. 1 pound is about 4 apples. So just something to keep in your head. All right, let's do another. I might save this actually. Take a snapshot of that. And I might keep that. Option snapshot. Okay. Clear all. All right, let's do another example. Let's do number 4. So number 4. Oh, this one's going to be. Let's copy that. This is just another way to get all the text in there without it going off the page. Okay. You push a grocery car, that has a mass of 30 kilograms, and you accelerate it at a rate of 2 meters per second squared. How much force are you applying to the grocery cart? So What's given? So given. I see kilograms, that's mass. I see meters per second squared, that's an acceleration. What's unknown? How much force? So we don't know F. So what equation are we going to use? We're going to use F equals mass times acceleration. Now we're going to substitute 30 times 2 and solve. Force equals 60, and the units of force are newtons. 60 newtons. That was number 4. We'll do one more. So these aren't too hard. They're very simple formulas. I'll do number 6. Number 6. All right, again. There's some info. All right. So you push your little cousin in a wagon. You pull her with a net force of 90 newtons to accelerate her at a rate of 2 meters per second squared. What is the mass of your baby cousin in the wagon? All right. So what's given? We know the force is 90 newtons. We know the acceleration is 2 meters per second squared. The unknown, they want to know what is the mass. So what equation are we going to use? We're going to use mass equals force divided by acceleration. So then we're going to substitute. So 90 newtons divided by 2 meters per second squared. Now we solve. So I got, oops. So I got mass is equal to 45 kilograms. So again, you might be asking, like, how do we get kilograms? Remember, newtons is the same thing as kilogram meters per second squared. So the accelerations cancel, and all we have left is kilogram. So that's my answer. And that's how you'll do these. Not too hard. Might take a little while. do as much as you can, turn them in, and that'll be 100.